Today we'll do 0620 paper 2, May-June 2024. This is variant 2 of paper 2. Let's start it. Question number 1. Which gas has the slowest rate of diffusion? Now, for the gas to be the slowest, it means that it should have the highest molecular mass. The one with the higher molecular mass moves the highest molecular mass will move the slowest. So we need to calculate the molecular mass for hydrogen. It's 1 into 2. That means 2. For NH3, nitrogen mass is 14. And hydrogen is 1 multiplied by 3. Total 17. For methane, CH4, carbon is 12 plus hydrogen 1 multiplied by 4, which gives us the mass of methane 16. For carbon dioxide, carbon is 12 plus oxygen 16 into 2, 12 plus 32, which gives us 44. So here you can see that the highest molecular mass is of carbon dioxide. So carbon dioxide, D, will be our option because carbon dioxide molecules will move the slowest. Next question. Which statement about the position of elements in the periodic table are correct? About the position. So, the elements in the same group have similar chemical properties? Yes, it's correct, because the elements which are present in same group, they have same number of electrons in their outer shell. The chemical properties depends upon the valence electrons. The electrons, the number of electrons present in the outermost shell. And then the elements which are present in same group have same number of electrons in their outer shell. So it means their chemical properties will also be the same. The elements in the same period have similar chemical properties? No, because the period number tells us the number of occupied electron shells. Elements in the same group have same number of electron shells? No, because elements in the same period have same number of electron shells, not group. The group number tells us the outer shell electrons, not the shells. Number 4. Elements in the same group have same number of outer shell electrons. That's correct. That's what we discussed in point number 1. That the elements in same group have same number of outer shell electrons. That's why their chemical properties are also the same. So option B, 1 and 4 are correct. Next question. Which statement about isotopes are correct? Now, isotopes. What are isotopes? These are the atoms of same element having same proton or electron number but different neutron number. So for the isotopes, their proton number or electron number is the same, but neutron number is different, and they are the atoms of the same element. Now, which statement is correct about them? Isotopes are atoms of different elements? No, they are the atoms of same element. Then, isotopes of the same element have the same chemical properties? Yes. As I told you in question number 1, that chemical properties depends upon the outer electrons. And in the isotopes, the electron numbers are same. So if the electrons are same, their chemical properties will also be the same. Isotopes are atoms with the same relative atomic mass. Is their atomic mass same? No, because atomic mass is the combination of proton plus neutron. And if the neutron numbers are different in the isotopes, that means their atomic mass will also going to be different. Isotopes of the same element have same electronic configuration? Yes, because as they have same number of electrons, they have same electronic configuration also. So option 2 and 4 are correct. It means the answer is C. Next question. Which diagram shows the arrangement of the outer shell electrons in the molecule of water? In the molecule of water, H2O, if we see hydrogen atoms, they have only one electron in their outer shell, which they're going to share. And as for the oxygen atomic number is 8, so its configuration will be 2 and 6. It's going to have 6 electrons in the outer shell, which makes the need of oxygen as 2. Oxygen needs 2 electrons, so it's going to share 2 electrons out of the 6 electrons. So out of 6, 2 electrons will be shared, and then the rest of the 4 electrons will be unshared. So let's see which diagram is the best. C. Because in C, as you can see, that each hydrogen has just one electron indicated by dot, and they are sharing that 1 electron. As for the oxygen, there are total 6 electrons. They're sharing 2 electrons, and rest of the 2 electrons are outside. They are called lone pair of electrons, the unshared pairs. So the answer is C. Question number 5. The structures of 3 substances are shown. 1, 2, 3. These which substances are hard and have a high melting point? Now, all these structures are of the giant structures. They are giant covalent structures. Now, you have to remember that which structure is of which substance. Part A is of graphite. And question number 2, this part 2, this diagram 2 is of diamond. Diagram 3 is of silicon oxide, silicon 4 oxide. Graphite has a layered structure, so you can identify from here that graphite has a layered structure. These are 2 layers which are attached with each other with a weak bond. Diamond and silicon oxide have the almost similar structure, but diamond has all same type of atoms together. All same type means all of them are carbon atoms. In silicon oxide, there are 2 different type of atoms, silicon and oxygen. So you can see in the diagram, there are some of the molecules, some of the atoms which are gray, and some of the atoms which are black. So hence, this structure is of silicon oxide. Now graphite, as it has weak bonds between the layers, which makes the low melting point of graphite. Graphite is not as hard as diamond or silicon oxide. It is soft, it is used as a lubricant, and it has a low melting point. So the answer is diamond and silicon oxide 2 and 3. They are really, really hard structures and they have high melting points. Next, question number 6. Information about 4 substances W, X, Y, and Z is shown. Melting point, electrical conductivity. Melting point 1710 does not conduct when solid. X, it also has high melting point, very high melting point, but it conducts electricity when solid. Y, melting point is low, it does not conduct. For Z, melting point is also a bit low and it conducts when molten. W, X, Y, and Z are graphite, polyethylene, sodium chloride and silicon oxide, but not in that order. What are W, X, Y, and Z? So, as we can see, for the first one, for X, its melting point is very, very high and it conducts when solid. So it could be graphite. For the next one, for W, its melting point is high, but the electrical conductivity, it does not conduct when solid. So it means it's not a metal. It is not graphite because metals and graphite can conduct in the solid form. So if it is not conducting in the solid form, that means it's not a metal, not a graphite. It can be an ionic compound, or it can be a giant structure which does not conduct electricity. So its melting point is very high as for the giant structures, but it does not conduct electricity like giant structures, diamond and silicon oxide. They don't conduct. Although their melting points are high, but they don't conduct. So it can be silicon oxide. Then why 120, its melting point is low and does not conduct electricity. So these two signs are completely showing that that's something insulator, which does not conduct electricity. So it is polymer polyethylene, which is plastic. Z, melting point is a bit higher and it conducts when molten. So it can be the ionic compound because ionic compounds do not conduct in the solid form, but it does conduct in the molten form. So the answer is D. The structure of glycine is shown. Which row is correct? You have to tell the formula of glycine and the number of different elements in glycine. Now, as for the number of different elements, we can count that there is hydrogen, there is nitrogen, there is carbon, and there is oxygen in the formula. So the different type of elements, they are 4. Now let's see the formula. The formula, we have 1 nitrogen, we have 5 hydrogens, 1, 2, 3, 4, 5, 5 hydrogen. We have 1 and 2, 2 carbons, and we have 2 oxygen. So from this, we can identify that the formula is C2H5O2 and N, and the number of different elements 4. So the answer is B. The incomplete equation for photosynthesis is shown. This is an equation of photosynthesis, but it is incomplete. Compound P is a product of the reaction. We all know that in photosynthesis, the compound which is formed is glucose, C6H12O6. Which row describes the values of W, X, and Y and gives the formula of compound P? So the empirical formula of compound P, we can simplify it from the table of 2 or by the table of 6. We can do it. So 6 ones are 6, 6 twos are 12, and 6 ones are 6. So the empirical formula of the compound is CH2O. So the answer could be from A or C. Now, if we see the balancing W, X, Y, let's write the equation here. CO2 plus H2O gives C6H12O6 plus O2. Now we need to balance it. As we can see, on one side, on the product side, we have 6 carbon atoms, so we'll write 6 here. On the reactant side as well, As for the hydrogen atoms, we have 12 hydrogen atoms on the product side, H12. And on the reactant side, there are 2 hydrogens already. So if we write 6 here, then it will make it 12. And as for the oxygen, if we see the oxygen atoms on the reactant side, then here for in carbon dioxide, 6 into 2, there are 12 oxygen. And here, 6 into 1, we have 6 oxygens. And there are 6 oxygens already written in glucose formula, C6O6. And we have to complete this 12 on this side with O2. So if there are 12 on the reactant side, so if we write 6 here, so it will make it 12. So as you can see, 6, 6, and 6, all W, X, Y are same. So the answer will be A. The concentration and volume of an aqueous alkali are known. Which additional information is required to calculate the number of moles of acid needed to neutralize the aqueous alkali? Now, what additional information is needed? Alkali, for alkali, the concentration and volume is given. Concentration and volume. And we want to calculate the number of moles of acid. So if one substance is given to you and we need to find the other substance, then we have to take the ratio between them. So what we can do from the concentration and volume given of alkali, we can find out the number of moles of alkali. And from the number of moles of alkali, we can find out the number of moles of an acid by taking the ratio from equation. So in that case, the equation must be given to us. So the answer is B, the equation for the acid-alkali reaction. It should be given so that we can take the ratio. Question number 10. Which statement about electrolysis is correct? Electrons move through the electrolyte from cathode to anode? No, because through the electrolyte, ions move, not the electrolyte, not the electrons. B, electrons move in the external circuit towards the cathode. It's correct. Because when we make the diagram, of electrolysis, there are 2 electrodes and they are connected to the positive and negative terminal of the battery. One is positive, the other one is negative. So from the positive side, when we connect it to when we give voltage to it, there is a push on electrons. So from the positive side, from the positive anode, which is electrode, from the positive electrode, the electrons go outside, which makes it positive. The electron starts moving out of the anode, and by passing through a battery, they enter into the cathode. The electrons enter into the cathode, which makes cathode negative. So the electrons in the outer circuit, in the external circuit, the electrons move out from the anode. After traveling through the circuit, they enter into the cathode. So they move towards cathode. Answer B is correct. Negative ions move in the external circuit towards anode. Wrong. Positive ions move through the electrolyte towards the anode. This is also wrong because positive ions are positive. Anode is also positive, and like charges repel each other. Positive ions, they never go to the anode because they're positive and positive.